Hello and welcome to Dan Makes Things. I have been building a companion robot, as hopefully most of you already know from previous videos. And I've been taking this poor guy apart at the moment because I'm trying to improve the range of motion on this knee joint. So as you can see at the moment, we have a foot and an ankle, and then we have the lower leg and the knee, and then we have the upper leg and the hip joint here. Now, although this has got a small block in to stop that from moving so that it can sit on the block, the range of motion of the ankle is pretty good. We can actually get it to go all the way forward and really all the way back to the point that it's touching the ground. Unfortunately, the knee joint is much worse than that. So this is actually as closed as that knee can go. And obviously it can fully extend and then extend back over to the same amount. So it's effectively a 90-degree joint. And what we've found is that if we make a small modification to a couple of parts within this joint, we can actually go through and give it another 35 degrees or so of range of motion. I wanted to do a deep dive of how I build things in the 3D modeling tool, which at the moment is Onshape. I pre-recorded the process of creating the new files, and I'm going to do a voiceover and talk you through everything. It will be quite long, so I won't have time to fully edit it as I normally would do, but hopefully it'll be useful to everyone. And if there is any questions, feel free to add them in the comments or join our Discord server. If you're not interested in following along, maybe this is a video for you to skip. But otherwise, I hope you enjoy and get some value out of it, and thanks for watching. So I'm using Onshape for this, and I started out with some imported models from the previous version. So the servo support and then the gear itself imported, and then built the new design around it, which works well, but it's less flexible if you want to make adjustments. So I started taking a look at doing a second design again from scratch, using the same parameters and measurements from the original, but basing it on the hardware that I needed to fit in place. So you can see here I've got the measurements for the servos in variables down the left-hand side of the screen. I've also got the measurements for the various fixings and bearings and that kind of thing. So we have a few bolts and screws that we use for this project. And it means that if you have a different size of bearing or you have a different size of servo, you should be able to adjust these measurements and then print the new design to fit your particular piece of hardware, whatever that might be. All I'm really doing here is rebuilding that servo support using those measurements. So you always start out with a sketch, which is the kind of 2D representation. This is in Onshape, which is free to use for hobbyists. And then from that sketch, you can extrude whatever it is that you want to. And typically you would have a height that you'd extrude it to. And again, I've set that up as a variable. And so it means that you should be able to just adjust things as you need to. So if your servo is slightly deeper or you'd like to accommodate more room, you can just change the relevant variable and have that work. Now, at the time that I started doing this, I didn't realize that you can actually create what's called a variable studio, which is another tab along the bottom where you can add all of the variables in a table and they can be referenced by all of the various part studios, which is what we're looking at now. But I did later on go in and add that. So when you see this file, you might find that there's a few duplicates there, and it's because I originally added them to the part studio directly, and then I moved them over to the variable studio as well. So just something to bear in mind if you're looking to repurpose this. And you can see sometimes I realize that I've forgotten a specific variable, so I'm going back and making one, and then all you have to do is you have to make sure that in the what is it called? In the timeline along the left-hand side, I guess, that variable exists before the place that you want to use it, so higher up in that timeline. And that means you can reference it within the sketch or the extrude or whatever it is that you're trying to build. And the other useful thing about this is, although all of the models are based on sketches and those sketches have been fixed, you can go back in the timeline, open up a sketch and change a measurement, and the entire build of the model will adjust where it's relevant to that measurement itself. So it means that if you do need to make adjustments, you don't need to go through and rebuild the entire thing. The dashed lines on the screen are construct lines that aren't actually used for the model, but are used for helping to make sure the dimensions are correct or aligned or whatever it might be. So you can see the diagonal one in the gap in the middle is just an easy way of me being able to find that center point in order to put the center construction line and then use that as a reference as well. And you can see here that I'm adding in the spacers for the screw holes, and they're specific to the servo, and that's one of the areas of this model that I'm not particularly happy with, because if I was to use a smaller servo, it might only have one screw hole, which is right in the center of that little section, whereas the larger ones that I have at least have two. So you would need to make that adjustment if you were looking to make this work for smaller servos, which I'll show you in a second once we get this part created. And what I basically do is set the diameter based on a variable, and then I use the various construction lines, like this one that I'm drawing now, to mirror that part. So if you change the measurement, it should update to all of the mirrored parts as well. So you select your mirror line, and then the element that you want to mirror, and just do that a couple of times in order to get the 4 screw holes there. And there's a couple of ways you can manage screw holes, because you can either have it so that they are wider than the thread, and so the screw will just effectively slot straight through, or you can make it so they're slightly narrower than the thread on the screw, and then you can use what's called a tap, which effectively creates a thread within the printed plastic. And then once you do that, you can actually use that for the screw receptacle, if you like, so that it kind of bites in as you're screwing in, and that becomes the fixing rather than having to have a bolt on the other side, or a nut, I should say. You can see some tolerances there, and what I've done is I've created a few variables for a small, medium and large tolerance, and that's really just to make sure that when we are printing this, there is room and accommodation for the fact that 3D print isn't perfect, and it does need a little bit of a kind of more of a gap in order to accommodate the parts. Now, the reason why I created variables for those is because, you know, if you decided to have this machined, for example, the tolerances can be a lot smaller, and you should just be able to adjust the small, medium and large tolerances and have the part fit a lot more snugly than it would do if you just left it as it was. So you can see here again, I'm doing another extrude, just trying to make sure that there is a gap for the head of the screw, but also enough material that the screw won't just kind of break through once you tighten it, and there's some decent structure to the design. Setting things like a starting offset means that you can generally do a lot of the work that you need to do based on a single sketch. But you can also define planes, and those planes allow you to create a new a sketch offset from the original X, Y, or Z axis. And that just allows you to kind of space things out a little bit, or gauge where your parts are going to be relative to one another as well. These are all things that it's useful to understand if you're going to be doing any kind of 3D modeling, just to make the process a lot easier. So you can see on this one, for example, I have a starting offset of 8mm, and then whatever it is that you want it to do. In this case, I want it to remove some of the material, and I want it to remove 5.2 mil. You can also, rather than setting those values to blind, which is a fixed value, you can also have them, for example, going up to the next face on the part, And again, that means if you adjust things, it will just adapt. But because I'm using these variables and they should all reflect those changes, if any changes are made, there's not really any need for me to do that. So here what I'm trying to do is understand how I can create a kind of hexagonal hole in order to put the nut for the nylon standoffs. And again, I have the dimensions defined, but I don't know exactly what the part was called or what the tool was called in order to do this, but I eventually found it up at the top there because it is, when it shows up, there we go, the inscribed polygon or circumscribed polygon, and you just pick the right one, and then you can set the diameter, but also the number of sides as well, and obviously that's how I achieved this part of the design. And again, both the diameter and the number of sides can be set as variables. So if for some reason you have standoff screws that use a slightly different number of sides or whatever it might be, or they're a different diameter, you can just change that variable and it will adapt. Sometimes when you're making a design, you'll see the measurements or the constraints show as red, and that just means that you've kind of over-constrained your sketch or your part, and you sometimes just need to look at it and work out what it is that you've done wrong. So you maybe have said that something needs to be a certain distance from something else, and then you've had another distance measurement set, and those two don't add up to the total width of the part or the element or whatever it might be. So it takes a little bit of getting used to go through and get all of that working. I'm not an expert myself, as you can probably see from this, but it's generally quite easy to work with in order to figure out what it is that's gone wrong and what it is you need to do to fix it. And here you can see that same mirror tool. So I set the mirror line, and then I just actually go in and individually set a mirror on each one of these edges. There's probably a better way of doing that, but I don't know what that is. And then again, I'll do the same. So I just escape out of it, go back into it again, and then do it for the other side of the servo. I generally try and make sure that the sketches are at least named in a way that I can understand what they are. It's not often necessary to go through and rename all of the extrudes and all of the other tools that you've applied, because you can get the context from that, because it actually highlights the change that's been made by that particular element when you hover over. But certainly from the sketches, it's useful to understand what you were building when you created that sketch, because as the design gets more complicated, it becomes quite difficult to keep track of, I found at least. You can see here I'm selecting two circles, and in the bottom right hand corner of the screen you can see a distance there, and this is really useful if you need to check any measurements that you've put in place to make sure they match up with what you're expecting them to. So in this case it's a 2mm gap, which is what I was hoping it would be, so I don't need to make any adjustments there. But you'll find that throughout this process I'm often just checking that measurements are exactly as I'd expect once I've extruded the part. And now I'm adding a slight recess so that those standoff spaces can slot into the part, just to make it easier to assemble. And I think initially when I was building this, I had the idea that the kind of flange from the servo, the bits that stick out the side that you attach the screws to, would actually go into the part and be recessed. But that isn't how I designed the original one. And in order to do that, that would make everything stick out the top a lot more. So I started out by recessing it, and then I think I changed my mind and just had it so that there was a small gap for a little piece that sticks up on that part on my model. But otherwise it was all flush with the original diameter, the original dimensions, I should say. So you can see I'm just adding a recess in there. Still useful to see how that happens. So this is that notch that I was talking about that sticks out on the top of the servo side flanges. If you don't put this in place, then on my servo it doesn't sit flush with the actual printed part. There you go, you can see a load of kind of over-constrained elements there, so I need to go through and understand what I needed to change. I couldn't quite see what that was there, but I obviously made some adjustment to fix that. And again, in this case, I'm just using a variable, but I'm not using a specific variable to this. There is a depth of the flange, and I just decided to use that same variable for this notch because it's a similar kind of thing. It doesn't need to be too specific, it's just to accommodate that. One of the other things that I added to the new design was rather than having the bearings just fit into a circular hole in the part, I wanted to have a little lip on one side so that when you push them in, they don't kind of slide out of the other side. And then the way that the part is assembled, when you put it into the leg, it means that they can't slip out the other side because of the fact that they have other elements that are holding everything in place. It was one thing that I wasn't too happy with in the original design. So all I'm doing here is trying to add a millimeter or two over the top of one end just to keep that bearing in place once it gets fitted. I think it takes me a couple of attempts to really get this correct, because I'm sort of making it up as I go along. So you can see this variable is the bearing outer diameter, which would be if you wanted it to slide straight through this hole. And then I think what I then do is subtract a small amount from that in order to make the lip, if you like, that I'm trying to put in place. And again, rather than having like 2mm as a fixed amount or whatever it is, I actually do 10% of the original diameter. So I make that 10% smaller than the hole, and that just means it's enough that the 3D printer will print something significant, but it will scale as well if we decide to do this with a smaller bearing. So this is a separate extrude. I do a starting offset, and again that's the variable, which is the full servo mount depth, which is the height of this extrude. And then we set a direction, and then we set a depth, and the depth I think is only a small amount as well. And because that extrude was set to add to an existing part, you can see that we don't have a list of a load of parts, even though we have a lot of extrudes. It all is just modifying that single part. So this is the point where I think I realize I don't need the flange to sit inside the part itself. So I just make a small change there, and you should be able to see eventually it corrects itself so that it sits flush with the outside. And in fact, what I did was just delete that specific extrude, and then you can see that everything just adjusts. So this is me just comparing it to the original design. You can see there was a little bit more complexity around those screw holes. I did leave room so that you could cut a section out in order to get the wiring from the servo in. But on this design, I decided to actually just make it so you unscrew the servo and feed it in, and then screw it back in again. You know, take the back off if you like, so you can flex the wire more than you could do otherwise. Because I found that as you adjusted things, even with that gap, you were still kind of chewing up the wire and things, and it caused problems. Now I'm just adding a chamfer, and that's again really essential because it's just accommodating as much room as it can for the rest of the leg. So when the leg folds, this is where that other leg actually sits. So it seems like a small change, but you actually get a much wider range of motion there, which is obviously very useful, and the whole point of the redesign, really. What I want to show you now is just if I make a change to one of the variables, the impact that that has. So you can see that I've changed the length of the servo there, and it just makes the hole smaller but keeps all the other dimensions the same, and that cascades throughout the entire design. So now, for example, if I change the outer diameter of the bearing, I think I've picked the wrong variable there, so I make another change in a second. Just undo that one. And the bearing large outer diameter was 22. If I make it 40, you can see the entire design just scales to accommodate that larger bearing. And that's really the idea behind all of this. If you wanted to use this to make a smaller pair of legs that use smaller servos, in theory, you should be able to just enter the diameter of the new servos and the new bearings and so on, and have it adjust. I think in reality, it's probably not as simple as that, but it'll take you 90% of the way there. And then there might just need to be some adjustments. So you can see there I'm messing again with the screw hole diameter just to see that it does change as I expect it to. And those mirrored parts also update, which is obviously something that I wasn't sure would happen before. You can assign both a material and an appearance to each of the parts as well. And so I try to make that look a little bit more like how it would print with my color scheme. And you can see I've also renamed the part, so this one is the servo mount. Then I create a folder called servo mount, and I actually include all of the changes in the timeline for this particular part. And that just makes it a lot easier to find everything if you do need to make any changes later on, because you don't have to worry about going through 100 different elements. You can just look in that one folder for all of the changes that are relevant to that part. So jumping back into the original redesign, you can see the parts that I need to complete. So we have the gear mount, and then there is also a little standoff underneath that. And the reason why I did that in two parts is because when you print it, the bottom of the gear needs to be higher up than the piece that connects with the servo mount component, if that makes sense. And I wasn't sure exactly how much space and so on, and I'm trying to build all of this without print supports. So what I decided to do was effectively just make like a shim that would separate the gear support from the servo mount component, and then I could adjust that and print it again if I needed to, and so on. So what I'm going to do here now is just go through and try and create that part. So it's effectively going to look like one piece once everything's molded together, but there will be two separate pieces. And again, that's quite useful because it means that if we need to adjust anything, we don't need to reprint everything, we can just reprint one of those. And when you create another sketch on top of an existing element, an existing part or an existing sketch, you can see that typically those dimensions that you've already added, those tools that you've already used, will allow you to kind of reference them, which I think is imprinting. I could be wrong there. So the idea is that, you know, it's a little bit easier to align everything because you're aligning it on top of the original part that you're then building something on top of in the real world. Generally, I would recommend trying to do this on a larger screen because obviously the more screen real estate you have, the easier it is to lay everything out. The toolbar at the top tends to hide a lot of the tools because there isn't enough screen size to fit everything in. I'm deliberately doing it on a smaller screen because I'm recording, but normally I wouldn't do it like this. So now with this part, there's the option to extend out further on the left-hand side. You can see it overlaps where the servo would sit, and that's because although I do need to have some accommodation for the servo, it doesn't need to be the whole way up to the top of the gear support. We haven't really talked about constraints yet, which is what you're seeing me select in the top corner. But the constraints effectively allow your elements of your sketch to rules around how they are linked to other elements of the sketch, I guess. So you can have things that are marked as coincident or parallel to another part, or must be horizontal or must be vertical, or whatever you choose. And there's a lot of constraints available within Onshape. I don't talk about them a huge amount because, to be honest, I'm not really too familiar with a lot of them, and I tend to just get by with a few. So if you are starting out on this, I guess don't be concerned, don't be nervous about trying things out. You can always undo them, and it will tell you if you have over-constrained your sketch, as we've seen when things turn red and you need to work out what's going on. And one thing I needed to do here was add another variable that is the distance from the servo mount screw holes to the center of the gear. And the reason why that's important is I'm trying to make all of these pieces fit with the original design because I've already printed it. I don't want to have to reprint the entire leg because I make small changes. So there are a couple of measurements that I need to make sure are identical. That way, if anybody wants to use this, they just need to reprint that section of the leg. They don't need to go through and reprint the entire design. And obviously that's quite important in this. So you can see now I'm trying to kind of gauge how I'm going to lay this out using construction lines just to understand what the dimensions, what the shape might actually be. And you can see there as I set up that parallel line, I actually touched it to the corner of the top line, and then it locked it and kind of allowed it to align vertically as well as horizontally, so that both of those endpoints were in the same place. And really all I'm trying to do is figure out the best way to build this. It takes a little bit of time sometimes because I don't always go in with a clear design, but you can make adjustments as you go, and you can delete elements and you can rebuild them. You'll see on the right hand side here that the edge of this is blue, and typically that means that the design is not fully constrained. So when I put that final dimension in there, you can see that turned black because that width was fully constrained. And then again, when I deleted the two construction lines, the top and bottom line became blue. So you've got to be a bit careful that you're not removing your constraints as you're going through and doing this. You don't always have to have a fully constrained sketch, but generally if you're doing something as specific as this, it's easier. It's easier in the long run to do that because it means that you're not going to have problems where your design shifts while as you're adjusting things and you don't realize because everything is constrained. And then here I'm basically adding the hole for the main joint bolt. And what you'll see is that I need to have the diameter of the bolt set. I need to have that tolerance that we talked about. And then I've got that separate outside edge, which obviously just needs to be, a bit thicker so that it can support the bearing or the bolt rather. And it's an 8mm bolt. So I've got 8mm and then I've got a decent amount of tolerance around it just to make sure that it doesn't get jammed. One of the problems I had in the original design was all of the parts were just too snug, and you had to end up like screwing this massive 8mm bolt through all of the parts, and all of them were moving independently, so you had to hold them steady with pliers, and it just became a nightmare. So the idea with this one is I'm going to try and make it so that the bolt will slot straight through, and then there'll be a captive nut or a locking nut, I should say, on the other side. So if you do need to disassemble it, you can do that quite easily by just grabbing one side with a pair of pliers and then using your screwdriver to unscrew that bolt. So you can see again, I'm extruding now just to see how high I might want it to be. And typically that's all dictated by those variables again. So I'll occasionally create another variable. If you're still listening to this, you're doing very well. We are half an hour in. It's originally, this was an 80-minute recording. I'm not sure what it's going to end up as. I'm not planning on cutting too much out, so we'll see how this goes. But yeah, if it's useful to you, that's great. If it's not, feel free to not watch it again. And you can see here for the depth, I'm just doing that same thing again where I'm taking one of the variables and just dividing it by 5. So I'm saying just make this a fifth of the overall height of the part. Now obviously that may not be perfect for every possible variation on this, but it just means that I don't have to have a variable for absolutely everything that's going on. And for the most part that should be fine. I think I then go through and make it a little bit thicker because looking at this it's obviously a little bit thin for the support that's needed. So once I have the basic layout defined, I need to go through and just adjust everything. I wasn't too happy with the the shape, with the look of this. So what I decided to do was actually make it so that it was a little bit more diagonal on the sides. That just gives a little bit more support as well, and hopefully that'll be more of an advantage in terms of the structure, and making sure that it's not going to fall apart once we actually put it under strain. Again, I'm just kind of eyeballing this and seeing, what I can do. I'm using the trim tool here to remove these edges. You can use keyboard shortcuts for that kind of thing if you're comfortable doing that. And then, yeah, maybe removing some of these lines that we don't need anymore. And you can see as I'm doing that, because those constraints are also being removed, some of the parts are turning blue because they're not fully constrained. I don't actually know that I did anything about that. I could maybe go back and adjust it, but it does the job for what we need for now. And sometimes as you make adjustments after you've already extruded, you'll see that certain parts don't look how you expect. You can see there I've had to include certain elements of the sketch that it didn't think it needed to include once I'd made that adjustment. And a lot of the rework is around just making sure that things are included when you make adjustments to previous steps, like the sketches and that kind of thing. So you can see there, I'm just making that a bit thicker, seeing what it looks like, completing the extrude, and then just kind of playing with it as I go, basically. So now that I've done that, I can start fleshing out what I need for the support for the gear. And as I mentioned, the gear originally was imported. So I think I generated that in Fusion 360, which I did use originally for the previous designs. And I imported that into this tool, but then it means you can't make any adjustments. And I recently found out that you can actually generate gears directly in Onshape quite easily. So for this version, I'm just going to generate it. And then that way, if I want to make the teeth smaller or more teeth or whatever, I can do that just by messing with that generated step. So this, again, I'm kind of just extruding that additional level to make it support that gear. So again, in the tools, I'm just going to search for spur gear, and that's going to generate what I need. For positioning of it, a part of the problem I had with the other one was that it just wouldn't align correctly, but you can actually connect it to a mate connector, which is allows you to mate two parts together, basically. It's quite a simple concept. And because I had a mate connector created in the center where I wanted this thing to sit, you can just bind it to that mate connector. Then you can set your depth and a few other variables. In this case, I wanted it to be a double helix, which just allows it to bind a little bit better and stay aligned a little bit better. It's probably not necessary, but it looks more interesting visually as well. And it's just as easy to print, of course. So it was just a case of going through and making sure that it matched exactly the gears that I had already. And again, that was because I didn't want to have to reprint all of the gears that were pairing with this one. I wanted to be able to just use it interchangeably. And so as long as I had the right measurements, I could generate this quite easily. Next we needed to make room for the bolt to go through the center. So again, I'm just selecting that same diameter circle from the sketch, and then I'm just doing another remove extrude, but this time including the spur gear, so that it can kind of cut a hole through the center of that, and that's basically it. And you see the merge scope there hasn't been defined, which is effectively which part you want it to interact with. And so when I select that, it then turns blue and we know everything's good. I think then I just have a bit of a mess around with chamfers and things like that just to see what it looks like. Again, this is more cosmetic. There's not really any reason to do this structurally, but it just looks a bit nicer and a bit cleaner. I think the final version has a slightly different way of doing this, but this is the basic idea, just to have a bit of a play. You can either select a face, in which case it will chamfer all of the edges that you've selected in that face, or you can pick edges specifically, and then of course you could have multiple chamfers with varying distances, which just means some of them will be more or less than the others. And then finally, for this part, I just want to combine them both together because I'm not going to print the gear separately to the support, so I'm just going to call that all part of the gear support. And then these pieces I want in blue, so I'm just editing the appearance and selecting the blue color. Really easy. So this is after I'd had a bit of a break and I decided I wanted to make this section a little bit thicker to be a little bit sturdier. So all I'm doing is I'm going in and editing the sketch. But as a result of that, there are assumptions that the code or the software makes in order to rebuild those extrudes that have happened after the sketch has been created. So you'll see here that when I go back to the main timeline, you've got this additional orange part, which was previously part of the main piece. And that's because that one section wasn't included in the extrude. So yeah, once you've adjusted that, everything kind of cascades down and it all seems to fit and work nicely. And you can see here what I'm doing is allowing space for the bolt head, which basically, because this was so much thicker, the head was sticking out the top, and it actually meant that the bolts that I had wouldn't fit properly. So this is an adjustment just to make sure that the length of the bolt is the right length to fit through the entire section of the leg. So I think I did a test print before I made this change, which is why there was a bit of a time delay between the two clips. And of course, it's easy enough to do that. You can print them in a few minutes. You can see there, because I've changed the sketch, that the make connector disappeared or wasn't bound correctly. So I just have to go back into that step, make the change again, reassign it, and then everything pops back into place. So although it is a little bit frustrating because it can't always understand what change you're trying to make, it's really easy to rectify any issues that you typically have. Skipping ahead a little bit, you can see that I then create another folder for this gear support and shim, which I'm just including in one folder because they're all very, very tightly coupled. And then that tidies up the timeline and I can move on to the next piece. So the next piece is actually the spacer that goes between the servo mount on the inside of the leg and the servo mount on the outside of the leg, which you can see here, because of course it's the same piece, so we just print that one twice. So this piece will fit between the two of them. It also accommodates room for the flange on the servo, and just holds everything together. So it needs to be a piece that extends through to the bolt, which is the piece, that 8mm bolt that we actually have in the center of the gear there. And it just obviously stops the leg from wobbling, adds that additional support, and determines the thickness and the distance between the two servo mounts that we will be printing as duplicates. So again, I'm doing a similar thing here because I was using at least the nylon standoff spacers, which are hex spacers. So I'm just using that as a basis to understand how I'm going to build this. Again, leveraging the previous sketches to make sure that things overlap perfectly and we don't have any misalignment issues and that kind of thing. And once I have that alignment in place, again, I can start adding in the circles that will become the screw holes. Now for this middle piece, because the dimensions or the length of those spacer screws is not long enough to go through the entire leg, what I wanted to do was actually try and thread this piece so that they could both bite into that and actually secure from both sides, have a screw going in from the inner leg or the inner side of the leg and a screw going in from the outside, and just have them both kind of meet in this part. So for that reason, I've made this one slightly narrower in diameter. And the idea really there is just, I can then tap it, like I was talking about before, and make it so that you can screw directly into it. Now, I will say that I've changed the design since I started doing this because, again, the nylon screws just weren't really the right length. The choice was either too short or too long, and I found that I was having problems there. So what I've done is I've actually ordered some bolts that go all the way through, made of metal, have a locking nut on the outside, and they will just go through the entire design. So I don't need them to be threaded anymore because the whole thing can just slide through, much like the larger bolt that goes through the gear. But what it means is that hopefully the structure will be a lot better and I won't have to worry about the nylon screws snapping or anything like that. But yeah, for now in this version, things are slightly narrower, but I do make an adjustment later on to correct that. Now you remember we mentioned that gear support shim. Because that adds additional height, we need some sort of spacer that goes between the bottom of the gear that you can see here and the bearing that's mounted in the corresponding part of the leg. And so all I wanted to do here really was build a small spacer. Now, in the previous version, these were very, very thin. As I said, they were too narrow, so they kind of got caught on the bolt itself. So what I'm trying to do here actually is do a little recess into the bottom of the gear. And then when I put that in place, I could potentially super glue it in place so that it doesn't move independently. But it also helps with that horizontal alignment or lateral alignment so that it doesn't slip as you're putting everything together and block the path of the bolt. So really all I'm doing here is adding a new sketch, making sure that it's aligned with that gap, and then adding space for a spacer. And again, I'm using an existing variable that is going to scale if any scaling is made by changing these variables at all. And you can see now that I have a kind of rough idea of how I want the spacer arm to look, the internal spacer, if you like. I'm just going to extrude it, I'm going to see what it looks like, and I'm going to make some adjustments. And I'm actually adding fillets onto certain areas of this here. And really the only reason behind doing that is to try and improve the strength rather than having sharp corners. Having kind of gradients just improves the structural integrity. Also, I've heard, I'm not a mechanical engineer myself, but I have played one on TV. So now that I have a first pass at these parts available, I'm going to right click on each one, click export. I do use the 3MF format rather than STLs. I found I've had more success with that because I did have some issues with my slicer. So that will trigger an export, and then in a couple of seconds it's going to come up with a pop-up to ask me where I want to save it. I'm going to go in and save it to the folder related to the 3D prints for this project. And again, because the part studio has a name and the part has a name, the file name kind of generates itself, which is really useful, and just a little tip if you're using Onshape. So I'm just going to go through and do this for all of the parts, and then we'll import them into our slicer and take a look at how we're going to lay them out for printing. The slicer that I use is Cura, purely because that was the one that was recommended when I started out, but there are quite a few options available, varying degrees of success people have. So I'm just selecting all of the parts that are relevant to this print and opening them in the slicer at once. And you'll see them kind of lay out more or less in the same way that they were in the model. So all I'm doing is I'm dragging them, and you can see when they're kind of striped and gray, shaded there, that they aren't on the build plate. So you've just got to make sure that you drag them and that they're also above the build plate rather than underneath. And once you've done that, you can see they should turn this color to indicate that. Now, I'm trying not to use print supports, which is pieces of material that you can snap off afterwards. But you can see in this case, I've had to rotate that part because the spacer that extrudes out at the bottom would have meant that the starting position would have been too high for the rest of the print. So all I'm doing is just turning it to make sure that it should print correctly. And if you go underneath, you can see the red and blue coloring, which indicates whether it is seating correctly on the build plate. And you just have to be a bit careful there. So I've noticed on this one, there are holes on both sides, and you won't be able to print that smaller hole above the build plate because it has nothing to adhere to. So there's a little trick for that that I like to use, which is if I go back into into Onshape, I can edit that part and I can just add a really thin layer to the first layer of that that smaller circle. So in other words, the screw hole itself rather than the gap for the screw head. And what that'll do is it means that when I start to print, it's printing using a technique called bridging, where it just bridges the gap in a straight line, rather than trying to draw a circle in midair, which obviously wouldn't work. So I'm just selecting the holes, and then I'm going to do an extrude that starts at that first layer, and I'm just going to make it a very small amount. I think I pick about 0.5 millimeter. It probably can be thinner, but it depends on the settings of the printer, so I like to give it a little bit of room. And once you have this in place, once it's printed, you can actually just take a screwdriver or a pair of snips or something and puncture that membrane and then just kind of file it away. And it takes a couple of seconds for each part, but it means you don't have to have a load of support material. You don't have to do anything more custom. It's quite an easy workaround. So you can see the difference there, that the hole has disappeared, but that plug, if you like, is only 0.5 millimeter thick. So it's easy to remove after the print's taken place. So I can export that again with the same file name, and then because it's imported already into Cura, Cura will refresh that design or that part on the build plate, and you can see it instantly update there. So now, although we still have that red, it's going to use bridging to bridge the gap rather than trying to do something it can't do. What I've done there is just right click and say arrange all models, and it just brings them closer together so the printhead has less distance to move between the parts, which makes it slightly faster, and it means they're also centered on the build plate, which is useful for bed leveling and that kind of thing. So yes, other than rotating one of the parts and sorting out those plugs, that's really the only thing that I needed to do. The plugs will be in place in the design, so you don't need to do that if you're printing this part. And you can see now I've done a preview, and with the preview you can get a feel for whether the layers are going to sit correctly. I don't use this very much, but if there's a part where I'm not quite sure whether both sides are touching the build plate at the bottom in the case of that gear support or anything else, you can kind of break down the layers and take a look and see whether layer 1 is being printed for all of the parts or whether one of them is slightly elevated or whatever it might be. So it's sometimes useful. It also gives you an estimate of how long and the amount of filament you're going to use. So then the final thing is just to save it to an external SD card, and then I plug the external SD card into my 3D printer and set it away to print. I'm using PLA Plus, printing at 210 degrees Celsius. And you can see here what that looks like on the build plate once it's been printed. So now that I have all the parts printed, I can start to assemble it. So you can see that plug that we talked about that's going through the space where the M8 bolt needs to go. I'm just going to try and pierce that with a pair of tin snips, clean it up a little bit, and then you should be able to fit the bolt through that gap. I also have the spacer printed out, and you can see how that fits into the recess. So you should be able to push it straight through rather than having to screw it into the parts because the gap was too small, which obviously was the case in the previous design. That then fits into the bearings. And you can see what I'll do is I'll remove that just to get a bit of clearance so I can play around, and then I'll put the actual gear back on the servo at the end. It's also important to remember that whenever you remove these gears, you need to do calibration again to make sure we're not attaching them at the wrong point in the servo's range of motion. Otherwise you could end up damaging the parts as well. You can see here as well, I am doing exactly the same thing for the smaller plugs that I put in place for the other smaller holes. That internal spacer and support, you can see that again the new bolt will go straight through the middle of that, so I don't need to screw into that or thread it or anything. I'm just going to clean up this part here. So unfortunately what I need to do is disassemble the hip, and this is still using the old assembly, and I'm not planning on modifying this just yet, so it is a bit of a fiddle to get it disconnected. I typically have to unscrew it with a screwdriver and pinch all the parts together so they don't move independently, and you'll see the kind of hassle involved in that. Then it's just a case of disassembling it by taking all of the nylon screws out. And what we're going to do is we're going to throw away those two white parts, the servo mounts, and then we're going to repurpose the bearings and use them in the new parts as well. Now, in order to remove and replace these parts, I actually do need to unscrew the back of the servo, so I'm just pinching it so that the front doesn't come off as well, because what you'll find is that a lot of greasy gears just fly everywhere if you don't hold that in place. But once you've removed the back, you can just move that wire out of the way, and then it doesn't interfere with the fitting of the part. Previously, as I said, I did have a space in there for that to slide through, but I found that it still got caught and I ended up with a few servos where the wiring was damaged. So this is the safer, more long-term option. So once I've swapped that out for the new part, it's just a case of fitting that back cover on again, and that's really the only part that needs to be fit before this is reassembled. Then I can take the other side of the servo mount and fit that in place as well, and that goes over the top, and obviously the screw holes then go into the flange and then into the spacers, and then they're secured from the other side with more screws. So you can start to get a feel for how this fits together now. We have those standoff spacers that fit into the hex holes in the servo mount, and then that other spacer fits on the other side there. I wasn't sure which way up this went. I put it in place incorrectly the first time round, but it's easy enough to change round. So skipping ahead there, you can start to see all of the parts coming together, and all I'm going to do is I'm going to put this large 3mm bolt, that's an M3 bolt through, and then the nut is a locking nut, and there's also a recess in the servo mount so that it doesn't turn while you're trying to screw it in place, and that's quite important because otherwise it's really hard to get it under control. You have to hold it from the other side with a pair of pliers or something as well. So hopefully this is a lot easier to assemble than the other one, and you'll see, yeah, it only takes a couple of seconds really to get everything in place now, which is nice. So once I have both of those bolts through, I test fit it to see whether it'll fit in place, and I've realized that I've put that inner spacer the wrong way around, but luckily it's just a quick case of unscrewing them to release them from the locking nuts, and then sliding them out and then popping that part back in the right way around. So then all I need to do is test fit it, and as you can see it's quite snug. It's designed to be millimeter perfect. I just need to put the spacer in front of the gear there, and then I'm going to hold that in place and just hold it with the M8 bolt and slide it in there. And you can see that it slides through easily, and then I can put the nut on the other side and just tighten that all into place. I will eventually replace these with locking nuts just because they do gradually loosen over time, and I'll get those on order soon. But you can see there the new improved range of motion and how low to the ground the robot will now be able to sit once I've done both sides. Now, unfortunately, the final piece of the puzzle is to put the hip joint back in place. That's going to continue to use the old layout for now, the old parts. So unfortunately, it's a huge amount of hassle to slide all of those back in. I'll not bother showing you the full process because it probably took me about 5 minutes. And once I finally have that hip joint reassembled, the final piece of the puzzle is just to put these screws in place that I didn't fit on the back end of those nylon spacers, just to tighten that joint up and finish everything off. So you can see a comparison there between the left leg and the right leg and the new lower position it can sit once that's been programmed in. And obviously again, this is all backwards compatible, so anybody who has printed the old leg should just be able to swap out the parts as I've shown in the video and get this, this improvement. If you've made it this far in the video, I'm very impressed. Go and do something else with your life now, and I'll see you in the next one. Thanks for watching.